There's a place on Earth where rain hasn't fallen for more than 4 centuries. The Atacama Desert, an expanse so dry that metal doesn't rust, corpses barely decay, and the air feels more like static than atmosphere. NASA tests its Mars rovers here because it's the closest our planet comes to another world. The soil is almost identical to Martian dust, sterile, scorched by ultraviolet light, stripped of nearly everything that once breathed. But when scientists scraped deeper, microns beneath the surface, they found something they couldn't explain. A single, impossible secret, dormant, patient, hidden for perhaps millennia, waiting for just a molecule of moisture to awaken. In the Atacama, one mistake means death by dehydration in less than a day. Yet life, whatever form it takes, found a way to build microscopic fortresses against time itself. So how does life exist in a place that killed everything else? And what does that mean when we point our telescopes toward planets that appear silent? This isn't Mars, but NASA has to remind itself which one is Earth. And beneath this sterile crust, something breathes. The Atacama isn't dry by accident. The Andes Mountains block rain from reaching the desert floor, while the Humboldt Current brings cold air that refuses to rise, trapping moisture before it can fall. The sun bakes the surface into cracked, salt-streaked bricks, reflecting a landscape that seems lifeless and eternal. Yet tiny clouds drift in from the Pacific. Fog hovers like a thin veil, carrying droplets too small for us to notice. Beetles, lichens, and hardy plants have learned to survive here, not by waiting for rain, but by breathing water directly from the air. In the cracks between salt crystals, life has learned to wait. One wrong step, one lapse in judgment, and death by dehydration comes in under 24 hours. Pause and notice your surroundings. Every drop of water you take for granted, every humid breath you draw, it doesn't exist here. The beetles see none. They taste none. Yet somehow, they extract enough to endure. But the breath isn't just in the fog. It's in something far smaller, far stranger. Above ground is only half the story. Below, secrets older than the desert itself remain hidden. The Atacama Desert isn't empty. Life persists in forms almost invisible to the casual eye. Beetles wander the salt flats, their legs coated in tiny bristles that funnel droplets from the dense morning fog. Lichens cling stubbornly to stone, secreting acids that draw water from minerals, extracting what the wind leaves behind. Hardy plants push roots into cracks, scraping moisture where it clings, fragment by fragment. These mechanisms are visible, tangible, delicate, and exposed to every degree of heat. The creatures aren't thriving. They're haunting the landscape, barely disturbing the dust. Every movement is cautious, every survival strategy minimal. But if macro life requires such careful engineering to survive, how does anything smaller endure in the soil? Above ground, survival is fought with visibility. Below, life waits without trace. The greatest survival strategy requires almost nothing. Not fog, not rock moisture, not even movement. Only the ability to vanish. Surface adaptations hint at something more extraordinary beneath the crust. The hidden life of the desert doesn't need to be seen to endure. Surface life fights with visibility. Underground, life waits without trace. Scientists scrape the barren crust, expecting nothing. Days pass. Sand and salt yield only emptiness. Then, a single lab result arrives. DNA. Not fragments, but complete sequences of life hidden in plain sight. Dormant, almost imperceptible cells cling to gypsum crystals, untouched for decades. Microscopes reveal forms so tiny, so faint, they exist at the edge of visibility itself. Nothing moves. No life as we know it. Yet these sequences confirm existence. The desert has been holding a secret beneath every grain of soil. Life persists despite millimeters of annual rain, relentless ultraviolet light, and temperature swings of 80 degrees. The mechanism remains hidden. NASA has drilled into the Atacama for decades, knowing analogs here could guide the search for life on Mars. But these findings challenge assumptions. Instruments might detect nothing, not because life is absent, but because it behaves in ways we never anticipated. Above ground, beetles hunt fog. Below, DNA whispers existence where no human eye can see. This changes detection protocols. Silence might not mean absence. It might mean we're listening wrong. Instruments that found nothing on Viking could have been reading the wrong signals all along. The genome is uncovered, but the implications stretch beyond Earth. What does this mean for Mars? And for the very definition of life itself? In 1976, NASA's Viking landers touched down on Mars with unparalleled optimism. Their instruments heated soil, added nutrients, and monitored gas emissions, looking for any sign of life. For a brief, electrifying moment, hope surged through mission control. But the results came back empty. Nothing stirred. Humanity faced the crushing disappointment of a world seemingly sterile. But the Atacama discovery tells a different story. Life here survives conditions harsher than Mars itself. The lessons upend assumptions. Instruments that returned nothing on Viking may have been reading the wrong signals all along. This raises a disquieting possibility. Every failed life detection mission might have succeeded, and we just didn't recognize it. The methods we trusted, the definitions we assumed might blind us to subtle, patient life. Which means our search for extraterrestrial life is as much about how we look as what we look for. The discovery in the Atacama is a warning. Silence can be deception. Subtlety can be life. Mars is no longer a blank slate. It's a test of our detection methods. And the Atacama microbes hold the answer. They've mastered survival through a mechanism that rewrites biology's rules. The question is no longer whether life exists in extreme conditions. It's how life survives them. And the answer lies in a biological strategy that seems to stop time itself. In the Atacama, microbes have mastered a strategy that rewrites our assumptions about survival. Cryptobiosis. Their metabolism shuts down completely, halting growth, reproduction, and chemical activity. Dormancy can last decades, or even centuries, until a single drop of water or subtle environmental change triggers reawakening. During suspension, DNA is actively maintained. Specialized proteins detect breaks, realign strands, and repair damage, protecting genetic integrity even under extreme heat, radiation, or prolonged desiccation. Life enters suspension when environmental conditions cross specific thresholds, then resumes when those conditions reverse. The process is automatic, triggered by chemistry rather than choice. Metabolic rates approach zero, yet structural and genetic maintenance continues. Some organisms survive decades in this suspended state, illustrating life's capacity to endure extremes far beyond conventional assumptions. This isn't adaptation across generations. It's a single organism rewriting the rules of what alive means. The microbes demonstrate something profound. Survival isn't about constant activity. It's about knowing when to stop and when to begin again. That lesson applies to more than biology. It applies to how we understand persistence itself, on Earth, on Mars, and perhaps throughout the universe. In the Atacama, life exists in ways we're only beginning to comprehend. Microbes persist in dust that hasn't felt rain in 400 years. Not thriving, not growing, just enduring, invisible and patient beyond human timescales. Such life survives on Earth's driest soils. Mars may harbor organisms we've already encountered but failed to recognize. The question isn't whether we looked, it's whether we knew what we were seeing. Life operates on timescales we barely measure, and forms our instruments weren't designed to detect. The Atacama doesn't just teach us about other worlds. It teaches us about limits. The limits of our assumptions, our instruments, and our definitions of what it truly means to be alive. Cryptobiosis shows that survival isn't constant activity. It's about knowing when to stop and when to begin again. This lesson applies beyond microbes, beyond deserts, beyond planets. It applies to persistence itself, on Earth, on Mars, and perhaps throughout the universe. Silence does not always signify emptiness. Sometimes it means waiting.